Hi, this is another past examination question from Core Mathematics C2. It's a January 2007 past paper and it's from Edexcel question number 7. So let's take a look. So we have this figure, and figure 1 shows a sketch of part of the curve C with equation y equals x into x minus 1 into x minus 5, and we need to use calculus to find the total area of the finite region shown shaded in figure 1, that is between x equals 0 and x equals 2, and it's bounded by C, the x-axis, and the line x equals 2. So if you're unaware in terms of how to work out the area between the curve and the x-axis, in particular how we calculate the area using integration, I have created videos on my channel and I'll provide links to those videos in the description below. Let me briefly talk to you about the process though. So let me pick up my favorite blue pen. So actually, instead of blue, let me take a red pen. If you want to work out in particular the area between the curve and the x-axis, all we do is we integrate y with respect to x between limits a and b. So that's how you would work out the area between the curve and the x-axis. One other important point is that any area above the x-axis will be positive when it comes to working it out using integration, and any region beneath the x-axis will be negative when it comes to working it out using integration. Now, area cannot be a negative, so we cannot have a negative area, so we're going to discount any negative in particular when working out the area of this region here, and the value is going to be negative, as I said, because when it comes to integration, any region beneath the x-axis will be negative when it comes to the answer when applying integration in particular. This area which is situated above the x-axis, that value will be positive in answer and when it comes to integration. So let me go back to blue and let me calculate this area above the x-axis. Let's call that number 1, and I'm going to call the area below the x-axis, let's call that region number 2. So first of all, let's work out the area number 1. So the area number 1 will be, we're going to integrate, the limits of 1 will be 0 and 1. So these will be these x values. 0, the lowest value will be the lower limit. 1, the highest value will be the upper limit. So 0 and 1. And y is given to us as, so let's copy out this y. It's given to us as x into x minus 1 into x minus 5. Now, before I integrate, let's expand these brackets. So if I multiply these two, x minus 1 times x minus 5, so x times this x is x squared, x times minus 5, minus 5x, minus 1 times x is minus 1x, minus 1 times minus 5 is plus 5. And if I simplify further, we'll have x squared minus 5x minus x is minus 6x plus the 5 at the end. So this is the outcome, bearing in mind when you expand these brackets here and here, but don't forget we need to multiply by x. So let's do that. X times x squared is x cubed. X times minus 6x is minus 6x squared. X times plus 5 is plus 5x. And we're integrating in terms of the form ax to the power n. So let me go back to my red pen. So if you're unaware of integration, again, I provide links to videos that I've done in the past and these videos have additional examples explained in a step-by-step manner, so be sure to check out those videos. But let me talk briefly about the integration process. So whenever you integrate, so let me write it down here, any term of the form ax to the power n, where a and n are constants, so we need to add 1 to the power to give us n plus 1, and then we divide by the result of adding 1 to the power. So we also divide by the n plus 1. Let me just add a c, since just for completeness purposes, since we're integrating an integral without limits. Now let me follow through that approach here. So since we have an integral with limits, let me open up a square bracket. So when I integrate x cubed according to this process, we add 1 to the power, 3 plus 1 is 4, divided by 4, the resulting power. Okay. When I integrate minus 6x squared, add 1 to the power, 2 plus 1 is 3, divide by the resulting power 3. When I integrate 5x, add 1 to the power, 1 plus 1 is 2, divided by the resulting power 2. Let's write these limits 1 and 0 on the right hand side. Now, before replacing the limits, I can cancel the 3 with the 6, it goes twice. And if I replace the upper limit, so the upper limit you need to replace first, upper limit is 1, so replacing the x's by 1's, we're going to have 1 to the 4 divided by 4 minus 2 into x replaced by 1, so 1 cubed, plus 5 into x replaced by 1, so 1 squared divided by 2. That is what you will have when you replace the upper limit, which is 1. When you replace the lower limits, which is 0, you'll get 0 to the 4. So 0 to the 4 divided by 4 minus the 2, x replaced by 0, so 0 cubed. Let me continue below here. Plus the 5 into x replaced by 0, so 0 squared divided by 2. So that is what you'll get as far as the replacement of limits is concerned. Let's follow this through. So from the first bracket, 1 to the 4 over 4 is simply 1 over 4. Minus 2 times 1 cubed is minus 2. 5 into 1 squared over 2 is plus 5 over 2. That is what you have as a result of the first bracket, minus, with regard to the second bracket, you're simply going to get a 0. And let's calculate this. So let's have a look. So 1 over 4 minus the 2 plus 5 over 2. So that amounts to 3 over 4. So you're going to get 3 over 4, and it's 3 over 4 squared units, since it's an area. And as you can observe, it's a plus 3 over 4, and that justifies our diagram, because if we go back to the diagram, the region 1 is above the x-axis, so we are anticipating a positive answer when it comes to integration. So that is justified by our answer here. Okay. Now we're not finished. We need to calculate number 2. So for number 2, we need to repeat the calculation, but the limits will be 1 and 2. So the lower limit is 1, the upper limit is 2, and we are anticipating a negative value because the region is below the x-axis. So let's see whether that is the case with the calculation here. So let me continue here. So area number 2. So we're integrating between 1 and 2. Now y, we've simplified y, so we had x cubed minus 6x squared plus 5x. So let me copy that down. So x cubed minus 6x squared plus 5x with respect to x. And we've integrated earlier, and we had x to the 4 over 4. So let me go down slightly. So we had x to the 4 over 4. So let me copy down this answer. Minus 2x cubed, so minus 2x cubed, plus 5x squared over 2, so plus 5x squared over 2. However, the limits differ. They're now 1 and 2. Now let's go to the next step. Let's replace limits. So if I replace the upper limit, so the upper limit you replace first, replacing the upper limit by 2, so replacing the x by the upper limit 2 rather, 2 to the 4 over 4 minus 2 into x replaced by the upper limit 2, so 2 cubed, plus 5 x replaced by 2, so 2 squared over 2, minus lower limit is 1. Let's replace x by 1 then, so 1 to the 4 over 4 minus the 2 x replaced by 1 cubed. Let me continue down here, so plus the 5 into x replaced by 1 squared over 2. So let me scroll down a little bit. So with regards to the first bracket, 2 to the 4 is 16, 16 over 4 is 4, 2 cubed is 8, times minus 2 is minus 16, and I can cancel one of these 2's with only one above. 5 into 2 then is 10. So that is what we have as a result of the first bracket. Okay, and if you think about it, the second bracket, we already calculated that. Okay, so using this answer from this first bracket, we had 3 over 4 overall. So let me take away, so from the second bracket, 3 over 4. So let's plug that into our calculators. So 4 minus 16 plus 10, and subtracting the 3 over 4, we should get a minus 11 over 4. Now, as I said earlier, prior to doing this calculation, we are anticipating a negative answer purely because that region is beneath the x-axis. However, area cannot be negative, so area has magnitude only. So we say in science that it's a scalar quantity. So let's discount that negative and just simply say 11 over 4 units squared. So that is the area of 2. Now going back to the question, we need the total area. So we need the total area, that is what is asked. So the total area means the area of 1 plus the area of 2. So let's continue. So I'm going to write an extra line, so total, so therefore total area, so that is equal to the area of 1 plus the area of 2. So the area of 1, let's remind ourselves, 3 over 4. So we had 3 over 4 for 1. Plus the area of 2, we had 11 over 4. When we do the summation, 3 over 4 plus 11 over 4 is 14 over 4. But that cancels to 7 over 2. So the answer should be 7 over 2, and it's 7 over 2 units squared, or squared units. So that is the outcome for question number 7, and that ends this question and sadly ends the video. So I hope you enjoyed this video. If you did enjoy the video, be sure to subscribe for more content like this, and I hope to see you again. Thank you.